Everyone, I am Dr. Anindita Raichodhuri and today I am going to discuss about one of the important data structure of R, which is matrix. Now what is matrix? In R, a two-dimensional rectangular data set is known as a matrix. In the matrix, elements of the same atomic types are content. Now we are already familiar with one-dimensional data structure, which is vector. In my another video, I have detailed description about how to create vector, what are the difference between vector and list. So I will give the link in the description box. Okay. Now matrix is created with the help of the vector input to the matrix function. Now we will see how to create a matrix. So the matrix is created using the matrix function, where I will now describe all the parameters of the matrix function. The first one, data, is actually taking the input vector, which is the data elements of the matrix. N row is the number of rows to be created. N column is the number of columns to be created. And by row takes true or false value. Depending on that value, if the by row value is true, then the input vector elements are arranged by row. And the last parameter, dim names, actually assigned the names of the rows and columns. So this is the syntax of creation of a matrix using matrix function. Okay. Now in first case, here we have taken by row parameter value as true. Okay. Now the first parameter is the input vector, where C function is taking all the elements. Then n row equals to 3 means the number of rows to be created is 3. N column equals to 3 means number of columns to be created equals to 3. And by row equals to true means now we are arranging the elements sequentially by row. So the vector elements are 8, 9, 10, 11, 12, 13, 14, 15, 16. So it will be arranged sequentially by row. See in this particular figure that here the elements are arranged by row. That means 8, 9, 10, it completes a row. Then the next element 11 starts with another row, 11, 12, 13. Then the next element starts with another row, 14, 15, 16. Okay. Now by default the by row value is false. If you don't mention, by row value is false. Now if we specifically mention also by row equals to false, then also it will take the elements sequentially by column. That means if we take the same vector input, then we will get in this case the matrix like this. Here the element will be 8, 9, 10 first column wise, then second column wise 11, 12, 13, then third column wise 14, 15, 16. Okay. So this is the meaning of the arranging elements by row and by column. Okay. Next, the last parameter, meaning of the last parameter, dim names. In the first two cases of creation of matrix M1 and M2, we have not mentioned the parameter dim names. But now in this current example, here we want to assign some names to the rows and columns both. So the row names here we have assigned as row 1, row 2, row 3, and column names we have assigned column 1, column 2, column 3. And now these values we are assigning as a list into the parameter dim names. Okay. So once we assign these values, that means we are passing the arguments through this function, then it will take it and the names will be assigned. in this figure you can see here that after that the matrix will be like this. Okay, here the elements will be column wise since by row equals to false in second case. So 8, 9, 10, 11, 12, 13, 14, 15, 16, and not only that, it is assigning the column name as well as the row name. Okay. Now how to access the matrix elements? A matrix elements is easily accessed by giving its exact position. Suppose we want to access the element of third row and second column. So here we have to provide the name of the matrix. Here the name of the matrix is M3, and the position, that means before comma it indicates the row number, and after comma it indicates the column number. So if it is 3, 2, that means third row, second column. Okay. Now suppose we want to access all elements present in a particular row, suppose in third row. So here we are assigning the row number as 3, but we are not assigning any value in column. So it will take all the values present in third row. The same thing happens with the column also. Here if you want to access all the elements present in second column, then we will not assign any value in row, we will just assign the value of column number and column here as 2. Okay, the name of the matrix M3, then column 2. So this is how we can access matrix elements. Now how to modify matrix? So how we can modify matrix? We can modify a single element, we can assign a particular value, we can replace a particular value. So first we will take the example how we can assign a value to a particular matrix element. So here again we have to give the matrix name, then the exact position, that means R, C means row number and column number. Okay, and V is the exact value you want to assign. So suppose you want to assign the value 30 to the element which is there at third row and second column. So name of the matrix here is M2, then third row, second column 3, 2, then we are assigning the value 30. So if we print that, we will get the value like this. Here it is red boxed to identify that here the value which was previously 13, 11, 12, 13, that value is now actually replaced by the value 30. But here we are actually assigning the value to a particular position. We are not actually replacing by matching the value. The next example I will show that I can also identify a particular value with respect to its value, then I can replace it also. So here in this case we are assigning a particular value to a particular position. So its previous value will be automatically replaced and assigned by the new value. So now in the second case, where we are replacing the element with respect to its existing value or previous value. So here if the value of the matrix element is 15, then only it will be replaced by 0. So here if M3 equals to 15, then it will be assigned by 0. So it is replacing the matrix element that is equals to 15 with the value 0. Okay, so this is another type of modification of a matrix. Now if I am not satisfied with only a single value, if I want to add more columns, add rows, okay, so these are also possible. We can add column, we can add row to an existing matrix. So cbind function is there to add a particular column. So here also we have to give the name of the matrix first, then the vector where we are giving the elements which you want to add as a column. So cbind, then the name of the matrix, then C function, within this the elements. So here you can see that after the cbind function uses, then we are getting that particular output. Okay. In demonstration part I will show everything using RStudio. Whatever I have done till now I will show in show that using RStudio. But for the time being, just try to understand that here after this cbind function, using this cbind function or execution of this particular command, we are able to add a particular column. Okay, so this column is added. Next, the same thing is possible with respect to row. In row, we can add a particular row using r-bind function. Here also the same thing. You have to provide the name of the matrix, existing matrix, then the value you want to add in a row. Here the values are 11, 22, 33. So here you can see that if I print here another point I want to mention, that in previous case I have just added to the matrix and just print it, but I have not assigned it to a new matrix, a new variable. But here what I have done, not only I have added rows, but I have assigned it in a new variable or new matrix, I can say new matrix M5, and I am printing it. So here also we can see that a new row is added in the matrix. Okay, so now I will start the demonstration part, where I will show how to create a matrix, how to access the matrix element, how to modify the matrix element, and also how to do the basic operations of matrix like addition, subtraction, multiplication and division. Okay, so let's start practically how to create matrix in RStudio. So here we have taken matrix M1, the same example which I have already described, and run it. See here, the values or the elements of input vector are arranged by row, because here the option by row or the parameter by row is actually set as true. Okay, so here the values like 8, 9, 10, then 11, 12, 13, then 14, 15, 16, the elements are arranged by row. Now similarly, if we try to create another matrix where the by row is set as false, let's see what will be the output. See here, the output takes the value column wise. Here, instead of row wise 8, 9, 10, here we are getting the column wise 8, 9, 10, then column wise 11, 12, 13, then column wise 14, 15, 16. So I think now it is clear what is the meaning of this by row equals to true and by row equals to false. In both of the cases, we have not specified the column names, column rows, but now we will specify the column name and column rows, and we'll see what will be the output. Okay. Now after assigning column rows and column names in the parameter dim names, see here we have assigned dim names equals to row names, column names in a list, and we are passing that argument. Okay. Now it is there to set the name of the rows and columns. The name of the rows are here row 1, row 2, row 3, and column are column 1, column 2, column 3. Okay, this is how we can set column names and column rows. Now how to access the matrix element. If you want to access a particular matrix element and assign some value, then this is the syntax. Here matrix name is M2. We are assigning the value 30 to the position of to the element having position third row second column. Okay, so let's run. See here, instead of 13, previously it was 13, 11, 12, 13. Now the value is 30. So we can easily assign value in any position of the matrix. Okay. Now if you want to replace a particular value based on the previous value, then this is a syntax that if you want to replace element that's previous value is 15 or existing value is 15, then you can use this particular syntax. If the here the matrix name is M3, and if the element is equals to 15, then it will assign the value 0 instead of 15. It will replace the value 15 by 0. Okay, so let's run. See here, instead of 15 here, the value is 0. Okay, so this is how we can replace the value. Now, instead of a single element, if you want to add a whole row, a whole column, is it possible? Yes, it is possible. I have already mentioned. But how? Using cbind and rbind function. So let's take another matrix M4. And here we will try to okay, let's see the matrix M4 first. Okay, the same value. Now we will try to add a column using cbind function. So add a column here. See here the column 17, 18, 19, this particular fourth column is added here. Now instead of column, if you want to add row, then again same thing using rbind function, you can do that. Here the row 11, 22, 33 is added. Here only difference is we have taken another matrix name M5 and assigned that whole thing into that particular new matrix. Okay. So this is all about how to create matrix, how to access matrix, how to modify matrix element. Now the basic operation of matrix. So these are the two matrix R and S. Let's create and print the value to show. Okay, so this is the matrix. Now simple syntax for addition of two matrices is just add two matrix and assign it into a variable and print it. It will give you the addition. Same thing for subtraction. So this is the result of matrix subtraction. You can see here. Okay. So addition, subtraction both are very simple. Now let's start matrix multiplication. This is also quite simple. Only thing you have to do that you have to multiply two matrix. Here two matrix are R and S. So you have to multiply it and assign it to variable and just print it. Okay. Let's see what happens. So this is the output. You can see it multiplies element wise. Okay. If you just carefully notice each and every element, you will find that just element wise multiply. And this is the division. So let's run it. And this is the result of matrix division. Okay. So this is the basic operation on matrix, matrix addition, matrix subtraction, matrix multiplication, and matrix division. Okay. I hope this video will help you in learning matrix and its operation, especially for the beginners. Thank you for watching. Thank you.